kind of actually starting to be a...
Oh, okay, this is progress for sure.
Yeah.
Hey everybody, welcome back to the Feature Crew. Super exciting news today. We finally got, on the first day of 12 days of OpenAI for Christmas, we got the first big Christmas gift, which is the full version of the O1 reasoning model. In Sam Altman's own words, it's the smartest model on the planet.
Yeah.
And so we're going to give it a try. They also released a pro mode for it, and we'll be taking a look at that later when we muster up the $200 for the for the subscription. But for now, we're going to take a look at the full model, which Sam claims will be good enough for most people, and we'll put it through the same tests that we put the mini and preview versions through. So check out those videos if you're curious for a baseline, and let's dive into it.
Cool. So here we are. O1 has rolled out. We have it ready to go, and we're going to get started with two real-world examples. So the first one we want to do, as often we do on the channel, is a coding example. So for this one, we're going to try and make a procedural kind of game that has a planet. And as you've noticed, we do have some materials prepared. We've seen that the new O1 allows you to give images. It's basically multimodal. So we're going to give it an initial prompt and then see how well it does, giving it maybe an image to see if it can like refine it. So trying real world examples first. We have no idea how it's going to go because it looks very impressive with math problems, but we do want to bias it towards how does it reason with real problems.
The prompt is pretty simple. I'm just asking it to use Three.js to make the planet, to render the planet, and it should all go in a single HTML file, which will just make it easy for us to run it.
So not bad. Thinks for 6 seconds. So as we're kind of scrolling through here, O1 seems to be a bit of an improvement over o1-preview, but the O1 Pro has a much longer kind of like test time compute. So this is already not bad. Like 6 seconds is like, it's kind of small.
It did some implementation of Perl and noise here, which is cool to see. Let's give it a run.
Let's give it a run. Okay. I made a very lumpy planet, but a planet kind of looking thing. It's got a bit of lighting going on. At least it rotates.
Yep.
That's not bad. And it was actually, again, quite a substantial implementation. The thing we're testing here, again, is its real-world ability to code with like a kind of ambiguous prompt. Because people are not necessarily always going to have these like hard math problems, and we want to test to see how good it's getting, potentially like from a agentic standpoint.
And this is something that should be in the training data, so it's not that hard of a problem. We're going to give it some feedback to try to make it work through a harder problem.
It's hard to say whether this is like a massive jump, but it's good to see that it's not regressed, right? So the next thing we're going to give it feedback is where we expect it to start being better, right? That's where these reasoning level models have to be better for us to be like, oh, this is impressive, because it's going to cost more, they take longer, and so on. So let's go ahead and give it a new refinement. So as Jacob does this, what we're doing is we're drawing an actual planet-looking object on the piece of paper. We're going to take a picture of that. I'm going to give that to O1. So based on what I did, it's already got kind of circular ball. So we're expecting it as a reasoner to recognize that, oh, like what you're drawing is a planet and I'm going to need to make edits to it. But we're going to try and be a little bit more ambiguous to see if it like kind of thinks about that.
First I'll show it to the camera here. I just did a very dirty drawing of a planet to indicate the triangles. So we have some mountains, some water, some grass with hills. I wanted to see if it picks up on those and then if it's able to implement this much harder challenge. Okay, so I put in the refinement prompt. Again, it's like, it's pretty simple, and we're trying to see how the model takes what we've given it, right? So I gave it the drawing that we just saw, and I'm going to send it off.
Intentionally ambiguous here. We didn't want to say, oh, like think about this. We tried to use color for water, greenery, mountains. Let's see, that builds in the previous code. We'll introduce more variation by layering, coloring based on elevation.
It didn't think.
Coastal green. It didn't think. I mean, if you go up,
Sorry.
I was going to say, it was looking like coloring based on elevation. So it got the blue, it got the green. You know.
Wait. It does talk about combining several octaves. This is the key thing I wanted it to do. I wanted it to figure out that it was using very simple Perl and noise, and that the way to make it more complex and make it more natural looking is to use multiple octaves. And then again, Dylan was pointing out that it understood the color. So first step here of understanding this image that I drew, you watched me draw in like 10 seconds. Very good understanding of the image, and then we're going to see if it can like take that which is effectively, it's written itself this nice long prompt here.
Yep.
And then we're going to see if it can take this prompt and actually implement it.
Yep.
Now, an interesting question is, because it was already going, like if we had given it this long prompt, would it have thought? And so maybe we should test that. Well, let's see what happens with the code here.
Resulting code first. I mean, regardless, this is still very impressive stuff. Looking back a year or so, right? Like, we are really getting to... They had tech demos where they did this drawing, and we're kind of actually starting to be able to...
Oh! Okay, this is progress, for sure.
Yeah.
We've got... It's doing the coloring based on the elevation.
Yeah.
It definitely has much more, like, varying terrain.
Yeah.
We could ask it to flatten the ocean or something, but it is really understanding sort of the problem here.
Yeah.
And then maybe I'll give it one more prompt just to see, since it's going fast, and I'll just say, like, think about how to make this better and more visually appealing and go for it.
Interesting.
Okay.
Subtle star field background, planet rotation. No way.
If it did all these.
To do it all in one shot. No way. I mean, it's still writing.
And it only thought for 5 seconds.
The details. Why is it not giving the thing details? That's interesting.
Because it only thought for 5 seconds. I guess it wasn't enough to generate. It doesn't actually give you the tokens. There's like some process in the middle where it decodes.
Yeah. No. Okay, makes sense.
All right. So it claims that the rotation, the star field, the atmosphere, and the color gradients. That's a lot of work. Let's see what happened.
If it actually did this.
Oh my God.
Did it get better? Is it rotating? Oh, it is. Wait, let's see.
It is rotating. You can
just barely rotating. It might be a little hard to see, but it's rotating.
It's
like
definitely rotating, and you can definitely see the smoothing between the colors. This is pretty impressive.
Yeah. And to be fair, this is our first React. We just tried to make some prompts off the top of our head.
And I want to make it clear that other models have really struggled with this kind of challenge in the past. Like Sonnet has gotten to that first step of having a planet, but to have the smoothing between the terrain and there are plenty of YouTube videos on how to do this, but it's still not something that models were able to do in the past. So this is definitely a bit of a step up in terms of coding ability here.
So we'll move on to the next one. Very impressive stuff. The next one we want to do is, again, another real-world example, but not like a hard problem, more of an ambiguous problem, where we're going to ask it about investing. We want it to give us a bit of a reasoning over should we invest money into, say, a stock. The first prompt we're going to do is focusing on kind of seeing it and testing its knowledge cutoff. So without giving any information, we know this is not web accessible. We want it to see, like, what does it think about when we give it this problem. So we're going to try that first. Then afterwards, we're going to give it some up-to-date information. Here's like a stock chart, and there's also a PDF we made with some previous information that ChatGPT generated, and we'll show that. And then see if it adjusts its reasoning. So let's go ahead and run this one. Or do you want to explain the prompt?
I think the prompt is pretty simple. I'm just asking, based on what you know, should we invest in Tesla? I'm trying to make it, prompt it to think a little bit.
Yeah.
But we'll see.
Think about this from multiple angles. Wow, it's clearly getting the right information here. Price wars, innovation beyond cars, energy and storage, autonomous driving.
Yep. And then this
Elon Musk factor.
In some ways, since it didn't think, this is really like asking for the question. So now we want to do the real question and say, like, let's give it some data.
Yeah.
We basically asked ChatGPT for like a detailed summary with a web search of everything that's happened in the last 6 months, which is a lot with Tesla and Elon Musk and the president-elect. And so I think what we want to do here is give it that information, give it some of the pricing information for the stock itself, and see what it's able to glean from that and what kind of conclusions it's able to draw. So basically, I've given it like that PDF text of just summarizing the last couple months of Tesla, then also the last 6 months of Tesla stock chart, and then I've asked it to like think deeply about all this stuff and then give us an analysis. What should we do today? And then also what should we do in the future if certain things happen?
So let's go ahead. It looks like it is thinking.
For 4 seconds.
4 seconds.
We can't get this thing to think.
And this could be O1 versus O1 Mac, Pro. I keep calling it Macs. I'm thinking like iPhones. But maybe the Pro variant is tuned to think more. Maybe they try and really ratchet it down given all the Plus users get this. But yeah, it's kind of strange. I thought it could think a little bit more. Maybe you give it a toggle to think more. But
right.
Okay, well, clearly it's picked up on all the information. Delivery targets, Cybertruck launch. FSD, this is all what we got from the web search.
Right.
And we can show an example of how to do the web search. We used ChatGPT to get this information. So you can think in the future, with web search, we wouldn't have to do this manual step. We're just giving it the manual step to test it out today.
And then this is interesting, the risk factors, because this isn't exactly something that was in the doc. So this is it starting to think, and it's saying that like it's currently high valuation. This is correct. Execution risk in new ventures, the autonomous robotaxis. So it's picking up on the stuff. Recommendation for today, it's saying it's got a lot of optimistic assumptions baked in. So it's talking about a cautious approach. I agree with this, right? There's been a lot of that. Clearly there's been a lot of response to recent news. And who knows how long that recent news is going to keep getting priced in, especially if, let's say, Elon's relationship with Trump changes. So this makes sense. It's a hold for long-term believers.
Yeah.
And then it's saying...
It's kind of interesting.
Right? Like, what could happen? So...
This would be a significant catalyst. So
this is where it's actually starting to think, right?
Like, I don't see many models making this kind of layout or this kind of approach, because this is now starting to get to, like, kind of novel territory where, like, what I just read there was kind of impressive. Imagine you're, like, an intern at, like, Big Four, and you made a document like this. This is kind of not bad.
And a lot of other models, if you ask it a question like this, we'll link the video where we've done this test before with other models, but often you get a very generic answer, right? The answer is like, if revenue goes up, then buy, right? Okay, sure. But in this case, it's applying it not only to the data we have, but the knowledge it has about Tesla and its business history and all that stuff. A better answer, certainly, than I've gotten in the past, even with little thinking from the model.
It's clearly thinking differently to like traditional models, and it's probably maybe even slightly better. The hard thing is this text output is very subjective. What some people might want is just one paragraph with yes or no. This is clearly kind of an in-between where it's like, hey, like I did what you said. I gave a detailed analysis.
This is a great... I love this little thing at the end. Even with the arrows, I've never seen this.
Yeah. But this is now looking like what a human would make, right? I can't even tell if a human wrote this or not. It's like this sort of level.
I think it's these types of questions are really hard to evaluate. So like I'm curious what the viewers find in their own use, and like definitely this kind of like subjective question. Do you think O1's doing better? Let us know in the comments. But I feel like this is a better answer than I'd get from 4.0. And I think what we'll need to do soon, we've talked about this, is do some comparisons with the full O1, compare it with maybe O1 Mini, compare it with 4.0, compare it with new Sonnet, and try to see really where these models are shaking out, where they're best.
Absolutely.
And so sort of moving on to our last test, we wanted to take a look at how the model performs with sort of agentic reasoning. Sam, at the presentation this morning, seemed to be hinting that this model is designed to be a good agentic reasoner. And so one of the most important parts of being an agent is planning and then executing on that plan in a way that actually achieves a goal. And one of the most well-known tests for this in humans is called the Tower of London. We can link to a video where we've run both O1 Mini and O1-preview and a bunch of other models through the Tower of London test. Spoiler alert, they've all kind of failed. There was like one time when O1-preview did okay. Other than that, it's really, it's been pretty tough. And so I will... paste in an image. So this image basically describes the test. So there's a starting state, and there are these beads on pegs, and you can move one bead at a time, and you can only move the top bead. And usually this is done with like a physical wooden toy. And so there's a starting state, and then you have to use your reasoning and do the least amount of moves possible to get to the goal state. And so we can see this pretty easily as adult humans watching this video that to get to the goal state, like you need to get the red off the green so you can move the green to the A peg, and so there's some swapping around that needs to happen, and then eventually you get to the end state. So like I said before, models have not always done well with this challenge. In fact, quite the opposite. It's been very much of a challenge, and to me that underscores why we don't have agents yet. And so with the claims of this model being the most agentic one yet, I'm very interested to see what happens when we send this test off. So now it's thinking. And it's interesting because we cut this out, but I sent it without deeper instructions, and it just thought I was telling it what the test was as opposed to asking it to solve it, and it didn't think. So this is the first time we've been able to get it to think for more than a few seconds. So we got it for 15 seconds, and we can see no details. Okay, so step-by-step solution. So let's give us a sec. I'm going to pull up the the visual so we can walk through it together. We'll see how well it did. Okay, so on the right we have our starting state and our goal state, and it's just like a free-form whiteboard. So I'm gonna, as we kind of walk through the steps that O1 took, I'll update it so we can verify its work.
Yep.
So let's first see if it got the starting. Yep, it understood the starting, and then it did not understand the goal configuration.
Nope.
Already a fail.
Yep.
Okay, so what we're going to do is copy and paste the text from here, correct it, and then we're going to rerun the prompt with the image and the text to see if it can grok it a bit better if it has both. Okay, so we're back. Redid the prompt. It now has the starting and goal configurations explained in both the text and the image, as well as the rules and the ask to solve the problem, and we'll see how it does.
So Elisa's thinking here.
Right, it's thinking for more than 2 seconds.
More than 2 seconds. And we'll continue testing this. We'll probably cut a little bit of this as we refined it. This is kind of a real-world understanding of how physics works and stuff like that, and a lot of models have failed here. So what we're going to do is, let's make sure we're just making sure the state it got is correct.
Yep.
Sometimes it misunderstands the image. And then we're going to copy its moves to make sure it was legit.
Yep, so we're going to do it on the right here so you can see. And we'll move, the move mode is to move the red from B to A, which is the correct move.
Yep.
And then it's going to move red from A to C.
Onto blue.
Wait, what?
Since blue is larger than red, this is allowed. I made some bad assumptions there.
Ay.
Move green from B to A. We place green on empty pick A. Okay, move red from C to B.
Red's moving all around.
Okay, we must so move.
I mean, hey.
Move blue from C to A on top of green. We verify the final state matches the goal state perfectly.
This would have been easier to read.
Yeah.
Yeah, but this worked well.
I mean, honestly, it's starting to show glimmers of it working properly. And I think if you scroll up, for some reason, it's been adding these assumptions about, you can only move big and small pieces, and typically the red one is smaller than the blue one.
I think it's confused because sometimes the goal, like in the normal physical puzzle, they are different size rings, and then I think the goal is that they're stacked, right? So that's part of why.
But this is definitely better. Like, I think o1-preview and Mini struggled with this.
Struggled.
Right? Yeah.
And it wasn't so easy as giving them a nice prompt and then they got it right. And so one thing that we'll do in future videos probably is try to scale this up and see like, especially as we're comparing with Sonnet, right? We want to declare a winner, and so we'll scale it up and maybe have 4 pegs or 5 beads and see if that starts to, make a problem. One of the good parts about this test is that while the rules for the Tower of London test are in training data, the specific instance is not in training data, right? Yeah. And so I'm pretty sure that it was able to reason through this and do something that looks kind of agentic.
So overall, kind of impressed with O1. As a first kind of look, this was just some immediate test we wanted to run. And it certainly seems to be performing better than o1-preview and Mini.
Yeah, this was the big... Tower of London was the big test for me. It's nice to see marginal gains on coding and maybe marginal gains on like business tasks, but its ability to reason through problems that it's never seen before and following the rules and using the tools that it's been given and then reaching a solution, like making a plan that actually gets it to the solution, is something that models have been sorely lacking, and it's what we need for good agents.
Well, it's real intelligence, right? Like you just assume these things are intelligent and they're not, and now we're starting to see glimmers of like, hey, like I kind of understand. I can't just like put this pig through, like it's actually understanding the rules and physics, quote unquote. So this is kind of amazing. Yep.
So definitely excited to see more of it. We'll be putting it through its paces, like we said, comparing it to other models. And one day one of us will bite the bullet and get the pro mode and try that too. So definitely subscribe if you want to stay along that journey. If you like the video, give it a like. Interactions really help us grow. We're still a pretty early channel.
OpenAI is kind of back. Hope there's some cool new releases in the next couple of days, and stay tuned for all of that.
And with that, we'll see you guys next time.